Okay, so for folks who are just joining, when Jesse's presenting, you're going to say, this is amazing. I have a lot of questions. The best way for Jesse to see your questions is if you use the Q&A box. So at the bottom of your little Zoom, if you hover, you'll see Q&A. Please just drop your questions in there and he will be able to answer them. We're going to do Q&A at 11:10. All right, so let's get started here. So Jesse, as I was just chatting, you have a really awesome background. So you're a data engineer, you're a creative engineer, and you're also the managing director of Big Data Institute. You work with companies ranging from startups to Fortune 100 companies on big data. This includes training on cutting edge technologies like Apache Pulsar, Apache Kafka, Apache Hadoop, and Apache Spark. And this stat to me is amazing, and this is something that I just want to clap for you for, but you have taught over 30,000 people the skills to become data engineers, and that's just amazing. So thank you for doing that. You're also widely regarded as an expert in the field, specifically for your novel teaching practices. You're published on O'Reilly and Pragmatic Programmers. You have been covered in prestigious publications such as Wall Street Journal, CNN, BBC, NPR, Engadget, and Wired. Jesse, you're so busy. Thank you so much for making the time to chat today. I'm going to mute myself and you take it away.
Thank you for that awesome intro, Rosalie. Yes, speaking of those novel teaching practices, I did record a video on understanding Kafka, understanding Pulsar with Legos. I have one on understanding Kafka with Legos. I just recorded a new one. Hasn't been published on YouTube yet, but be on the lookout for that. So that will help you as you come through this conference and you're trying to say, and it goes this way and this way. Send them that video, send your coworkers, send your manager that video. It's even pointy-haired boss friendly. That's why I try to make those videos. So let's talk about our itinerary for the next few minutes. I'm going to introduce Pulsar and talk about the differences in architecture and similarities. And then I'm going to talk about the API and some use cases. So to start off with, here's what Pulsar is. Pulsar is a distributed event streaming system. What does that mean? Means several different things. There's some loaded words in there of event streaming and distributed. Well, what distributed means is instead of running on a single machine, Pulsar runs on several different machines. It runs on a cluster of machines. And it's event streaming where we can send in an event and that event can be consumed by other things. There's also some really cool parts to Pulsar about it having a distributed log. And we're going to see this distributed log versus a commit log being a fundamental difference between Pulsar and Kafka. It was originally created at Yahoo, and obviously Yahoo was bought by Verizon. A lot of the folks you're seeing here, you see Verizon Media, that was the previous name. And then we have our open source. It was open sourced in 2016. Remember that because it hasn't been that long that Pulsar has been out in the community, and for that matter, hasn't been as long that Kafka's been out in the community. So what I see is definitely an adoption cycle that's happening here. If we have these two competing projects, let's educate people on what happens, what they can be used for. So to that end, we have Kafka. I define Kafka as a distributed pub subsystem. Once again, we have that same distribution. We have that same sort of, we have a cluster of machines, cluster of nodes. We no longer have a single point. But one big difference is this commit log. Apache Kafka adheres to this commit log, and there's going to be some architectural manifestations of that as we start to look through this. It was originally created at LinkedIn, and it was open sourced in 2011 and became a top level project in 2012. So definitely Kafka has some years of being out in the open source community longer than Pulsar. So let's see what happens now. Now that we have this, we have some momentum. You may not have seen it. You may have seen it as part of the emails for this, but we are doing a lot of firsts this week. For example, we're having the very first Pulsar Summit. And last week, I taught the very first professionally written Pulsar class. So we'll see some changes around that as a direct result. So let's start off by looking at our architecture. And this time we're going to talk about Kafka's basic architecture first. So here we have our publisher, and publisher is is I'm kind of expecting you to come in having a little bit of knowledge about Kafka and needing to fill in that Pulsar gap. So when we have our pub sub system, we have a publisher and a subscriber with Kafka in between. Kafka is going to handle three things for us. It's going to handle the receipt of the data from the publisher. It's going to handle the storage of the data into those commit logs. And then it's going to handle the consumption of that, the subscriber, getting that data out to those subscribers. And this stands in contrast to an RPC. Kafka, Pulsar are not great for doing RPC. Probably still room for RPCs in my opinion. RPCs being remote procedure calls. So let's compare that with Pulsar. Well, Pulsar does that same pub sub. So we have our producer, it produces into Pulsar, and we have our consumer that consumes from Pulsar. But now we see two boxes instead of one there. And one big difference, one giant difference between Kafka and Pulsar is that storage is being done by Apache BookKeeper. Now in this conference, we've learned a little bit more about BookKeeper, but this gives us our state. This is where all of those messages are stored durably. Pulsar itself, more correctly, the broker for Pulsar is stateless. It can be taken down. We can spin these up, spin these down. They're not the ones storing the data. So we have our cluster of BookKeeper right here. So big difference here in this architecture that we have the receipt sending around of data separated from the actual storage of that data there. Now let's take a look at partitions. In a very similar way, Kafka and Pulsar work on partitions. However, there's some pretty significant differences where when we produce data, it's going to go into a topic and then those partitions are going to be separated out. Now in Kafka, these are both logical and physical divisions, where logically we split it out and then physically on disk, those are separated. So in a very similar way, we have Pulsar ledgers where each topic is a stream. And then instead of it being stored in a commit log, what happens is that we are breaking that stream up into various ledgers. And then those various ledgers, once they're actually written out and once they're stored, we have these individual messages. And in that sense, it's very similar. But now instead of things being very tied to a partition, now what we have are segments. So we have these segments, and that is really the unit of how data is stored within Pulsar. This segment-based storage allows us to have more flexibility, a flexibility that we wouldn't have normally with Kafka. I'm going to get more deeper into that flexibility in just a second. But this flexibility also manifests in the storage itself, where we can store data a different way than we could with Kafka. Where with the partitions, those partitions have to be replicated a very specific way onto n number of brokers. Whereas with segments, we can change that around. We can actually do striping. There are some ways we can actually do some pretty interesting movement and saving. Now, one big difference that I saw with Kafka and between Kafka and Pulsar was around the producers and the relationships of how data gets moved through. So here we see kind of a basic data movement, but in Kafka, the producers are actually the arbiters or the ones who choose which partition data should go into. As you can see here, when we produce in Kafka, an actual partition is chosen right then. So we produce, and if we have a key, for example, a partition will be chosen. If we do round robin, a partition is chosen. And then the consumers of that data, the consumers only receive what those partitions that it's assigned to. In this case, we have one consumer, therefore it gets all three partitions. But it's very, very focused on those partitions. We don't break out of a partition. Once something is put into a partition, it is locked all the way through the system, all the way from here to which partition it gets saved into to how it gets consumed. Now with Pulsar, we actually have subscriptions, which is very similar. If you're coming from this Kafka, those are consumer groups. Well, with Pulsar subscriptions, we actually get something that is very unique and very different. And in my opinion, I think it's really going to be what gives us some real power with Pulsar. And that is when we produce is not, we actually choose a partition when we produce, yes, but the actual consumption is not tied specifically to a partition. So for example, we could have a key shared subscription, which is similar to Kafka's shared script consumer groups if we were to produce with a consistent key. Well, with a key shared subscription, what could happen is we aren't specifically tied to these partitions. What we're tied to is the key. So if we had 10 partitions, 20 partitions, the keys can actually be sent evenly or sent in an even fashion to those to those consumers. We could add more consumers to that. We have specifically broken out of this adherence to partitions, and the brokers will introspect into that key and route accordingly. Similar to this round robin, we could have our producers produced in with a consistent key to keep that ordering, but for certain use cases, we may want a consistent key, and for other consumers of that data, we may want a shared subscription. With Kafka, that isn't possible. With Pulsar, that actually is possible because the consumption is actually done right here at the broker level rather than at the partition level. There's another interesting one here with failovers where we can have a single consumer and a hot spare. So I wanted to show you a bit about code as well. So here, code-wise, this is what the code looks like. Personally, I don't like configuring things with Java util properties. I think that leads to either misconfigurations or a bunch of knowledge and types that just isn't, this isn't the way I want to do that, especially as you get into more and more complex consumers, you get into larger and larger amounts of data or number of properties that have to be put in there. We also have our Kafka producer, we create producer records and we send those and we close that, okay? Well, here's what the producer looks like. First, we create our client, and that client is kind of this holder that says, here's where our Pulsar cluster is, and we build that. Throughout the Pulsar API, I think they did a really good job of using builders, and these builders actually help us have types. For example, service URL is a string, and as we do other configurations to, for example, our producer, we do get a specific type. One other big difference I see between the two APIs is that schema is built in. Schema is directly put into the broker and saved in BookKeeper, whereas in Kafka, it's all layered on. You have to use other either companies' systems or do it yourself to reconstitute things. There isn't anything that specifically says, hey, this topic is always going to be strings. And if somebody throws an integer in there, we're going to get problems. With Pulsar, we actually do have this ability. So here, when we create our producer, we actually specify and say, there's a schema there and there's strings. There's UTF-8 strings that are there. And here's our topic. And once again, we're doing this builder. So we have actual types here. This is an enum and we have our types. Here, when we create our producer, we create a new message. We create our key and our value and we send that. On the consumer API, we're back to having a bunch of properties being put into our Java util properties. I still disagree with this route. I would love to see something better there. We have our brokers, we have our groups, we create our consumer groups, and we actually have to specify, here's our deserializer. And there is, although we should have tested this, there could be a split brain, there could be a disconnect, there could be issues there. In this case, schema is really not a first-class citizen within the API or within the entire system. Then we start creating a poll. We poll for our consumer records, and we can iterate through that. Here is Pulsar's consumer API. So when we create that client, what we have to do is we say, here's our URL, but we build that just like before. Now we have our topic name and our subscription name. And once again, that for the Kafka people, the subscription name is similar to the group ID that we just saw here. So here's our group ID, similar with obviously some nuances. So a subscription name there. And then from there, we create our consumer. We specify here is the schema that is coming in. So it's schema of type string, the topic we want to consume on, the subscription name for that consumer, and we subscribe. From there, we can start receiving, and we can receive those back. We receive those back as message objects. Once we have those message objects, we can get the keys and values from them. And instead of doing a commit of an offset, what we do is an acknowledgement. And this is actually very powerful. There's a few things that are in this consumer API that are very common asks in the Kafka community. Or as people start to learn about Kafka. One is the ability to individually acknowledge messages. What that means is if I receive a message, I can acknowledge that I've received it. And that works differently than Kafka, which is what's called a high watermark. We say, I have committed up to this point. I have committed up to this point. Now the difference there is, the difference between those commits is saying, I have committed this message, I have dealt with this message, and I have dealt with this message. And since we have that ability to individually acknowledge or individually act them, we can also negative acknowledge them. And you see that there in the catch. Let's say there was some problem. We can say, I received it, but I wasn't able to do whatever for whatever reason. Pulsar behind the scenes will retry that a configurable number of times. And if we can't get that to work, we can actually put this into a dead letter queue. We can put policies in there so that that message gets retried. Speaking of more development, there's been some interesting discussion about whether Kafka and Pulsar have kind of one-to-one relationships of what's out there in the ecosystem. For example, with Kafka streams and Pulsar functions. Well, not 100% feature parity, but saying that they don't exist, that there isn't a sort of stream processing thing. Hey, we could create something with Pulsar functions. I would also say we have Pulsar SQL. One thing to know is that KSQL DB, although my memory is that it's an Apache licensed, it is not part of an Apache project. It is part of Confluent, and that Confluent has made modifications to that license. Not a judgment, just more of a statement of, so you know this difference, whereas Pulsar SQL is part of the Apache Pulsar project. We also have with Kafka Connect, there are things that are better done with configurations. For example, it's very common to move data in and out of a database. I don't want to write this code. I'm going to use a framework. Well, we have frameworks for this. We have Kafka Connect and we have Pulsar IO to do this. I would also point out this for those of you who are thinking about how do I move to Pulsar? How do I start operationalizing this? Well, you can use the API. You can use this Pulsar API at different levels. One is a line protocol where we don't make any code changes. And the other one is at a code level where we go through and we change out the Kafka client libraries for Pulsar client libraries, recompile, but we won't have to make any code changes then. We would make library changes. So obviously a recompilation difference, whereas the Pulsar API, that the other way is a line protocol level usage. So let's talk about some use cases that we can work with for Kafka. For me, I would say I haven't seen a use case that Pulsar can't do. So in many ways, I think of Pulsar as Kafka++. It can do what Kafka does, what Kafka purports to do and we've seen do, plus some other things. And I think these plus some other things are really what's key or why. If you're a lead on a team or you're trying to figure out or push for some kind of change, I want to move from Kafka to Pulsar, or we're evaluating Kafka and Pulsar. One of the things that you want to do, or one of the pushbacks you'll get from management is this change for the sake of change, or are you actually doing something fundamentally different. So this is where I would look at as, yes, we can do all of what Kafka does, but what is that thing that the team can do that's different now that is new and unique? What is that special sauce that Pulsar is going to give us? One of the big ones I've seen is work queues. I wrote an entire post about this if you want to go to that minified URL. In a very basic sense, since Kafka has high watermark, you can't really do a work queue well on that. There are some backflips you can do when I talk about them in there. It's really not what you want to do. So put a different way is if you have tasks that run that aren't just very fast tasks, then you're probably looking at a work queue. Whether those tasks take 30 seconds or they take hours, this individual acking gives us the ability to say, I have done this task, whereas Kafka really has some difficulties doing that sort of workload. Read that post if you're thinking of that sort of use case. Another big one I saw is Geo Replication. If you're wondering about Geo Replication and what Pulsar can do as far as Geo Replication, go watch the talk that the folks from Verizon Media just did about their 5 years plus, or many years of using Pulsar with Geo Replication. If my memory serves, they were talking about 20 different clusters that are geo-replicated. Geo-replication is built into the Pulsar broker, whereas with Kafka side, it is done either with a proprietary software from various companies, or it is done with Mirror Maker, but it isn't done as part of the Kafka broker. It is done as a consumer. So what has to happen is you have to produce that, it has to get saved. There's a consumer that then sends that across to the other side, to the other cluster. It's my personal opinion, and it's a very strong opinion, that the best replication always happens when it is built into the server, in this case the broker of that, and shipped off that way. I think it's a significantly better way. And if that's a key use case within what you're trying to do, you should really look at that. The other one is unification. If you've watched some of the use case track, and I know I have, that was a big reason why some of the companies actually chose this, that they had both an MQ style cluster running, or not cluster, but service running, as well as Kafka. And now you have operationally two systems you're going to have to keep in sync and deal with operations for, and programmatically, now you have this one using this API and this one using this API. Lots of fun stuff there. But if you are able to unify them together and have a single cluster that can do the MQ style things that you need to do, and you can do the pub sub with that same cluster, operationally that brings your cost down. And we actually saw that during some of the use case talks of, yes, this brought our cost down. I think one person said 2 or 3 times. So significant amount of cost reduction by doing this. I would say that was just, in that case, straight operational. I would also say there was probably some development, some architectural cost reductions there too that I would be thinking about. So definitely think about, this is why we need this. I found, I've taught Kafka pretty extensively throughout the world, and I found that this to be a pretty consistent ask of, I don't want to throw my MQ away. I'm doing this MQ thing, and that's working okay, but now you're telling me I have to go use Kafka and I have to write this Kafka for this. Maybe that's not what we want to do. Maybe our main point is to initially get everything on a unified cluster and then go from there. Another one is lots of topics. If you watch the talk that Joe Francis did, and I can't remember the other guy's name, they were talking about, I think it was 3 million topics. If you go to talk to a Kafka person, they will curl up into a ball thinking about 3 million topics. And there's several reasons for this. Kafka, everything is in a single namespace. I shudder to think what the listing of topics would look like with 3 million. all in the same namespace. So what often happens at companies, especially large companies, is that they do a lot of prefixing. It's this business unit dash this group dash some topic name dash something else. It becomes lots of dashing where you have to kind of parse through and grep through and, okay, where am I at and which one am I working with? With namespaces, we can actually separate that out. We need, if you're doing anything at scale, anything across the enterprise, in my opinion, you really need those namespaces to keep things separate. But I would also say that those topics, having that many topics gives you some new things that you could do that probably couldn't think of otherwise. Whereas some of the companies I've dealt with, we've had to bring things into a single topic in order to keep that coherent, in order for other reasons, where we might have said, oh, you know what would be better is actually to keep those into a single, into separate topics for various reasons. And I personally have dealt with some of my clients, and if we would have had Pulsar for those use cases, we could have actually done some really interesting things that were either cost prohibitive with Pulsar, with Kafka, or just not even possible with Kafka. So do think along those lines, where with Kafka, we were relatively constrained. If you don't know it, there is a loose sort of limitation of about 200,000 topics. Another thing to know is one of my customers, they didn't realize, one, that topic limit, and two, how they were really constraining things down. So that limit was actually around, for every topic, they were actually creating several topics that were related to that. So if you're doing a similar thing remember, for every one topic, if you're creating an additional 2 that are part of that, your limit or number of topics is now divided by 3. And what I've seen companies have to do as a direct result is that they're now having to have separate clusters. We'll have this cluster for this and this cluster for that. And we really lack that economy of scale at that point. So definitely think along those lines of what can be done. So with that, I'd like to thank you for coming, and I will open it up to questions.
Awesome, Jesse, that was fantastic. Folks, if you have questions for Jesse, we have about 10 minutes for Q&A. So just go ahead and drop your questions in the Q&A box. Jesse, I have a question for you. So, you've shared knowledge with more than 30,000 folks. Question for you, if someone's new to Pulsar and they say, this sounds amazing, but they're totally new, how can they get started? What are like the 1, 2, 3 steps that will get them on the right path to using and contributing?
Sure. So I'll answer that 2 different ways.
Okay.
One is, are they brand new to streaming, period? Or do they have a background to streaming and they're looking to move from, let's say, Kafka to Pulsar? So brand new to streaming, they should realize that as much as some companies are saying this is easy, this isn't an easy transition. This is a complicated transition. Whether you have a background in big data or not, complicated, because we get into strict SLAs, we get into distributed systems, we start getting into real-time processing, and that's difficult. So just know that it's going to be an amount of time that is non-trivial. It's not, I'm going to spend a weekend and learn Pulsar. You may be able to learn the API of Pulsar, but actually creating a system with Pulsar is the difference. So what I would do if I were them is I would focus on thinking about being a data engineer. Doing data engineering is not just, hey, let me throw Pulsar in there and all of a sudden we have this spectacular system. It is, okay, well, we need to figure out what we do with Pulsar, what we do with Flink, what we do with this, what we do with that. How do we bring that all together? So to that end, we have the class. So Stream Native has a professional class that I teach about how we develop systems with Pulsar. But we also think that we also want to have our systems be ready so that we can actually generate business value. We are creating real-time data products. And remember that. For the person who is kind of pivoting, I would also recommend the same sort of thing. Make sure that you have an understanding of where Kafka, what nuances are there for Kafka, what nuances are there for Pulsar. I would strongly recommend a professional training. To toot my own horn, I've taught both quite a bit. Especially in those teams, if you are looking or moving, to be able to ask a true expert those questions and have that level of guidance, it doesn't accelerate your team by just a little bit. You'll find that it will accelerate your team by, I've had my clients tell me months. So really do think about that.
Wow, that's fantastic. So Jesse, if you look at your Q&A box right now, there are a lot of questions. Folks are asking all types of questions. So if you want to take a stab at it, that'd be amazing.
Sure. So here, one from Abatilo. He says, do you offer classes for training? From operations, no. There isn't an operations class yet. You'll want to get with Stream Native about that. They're the ones closest to doing an operations. But yes, as of now, it is just for developers. Okay, what use cases is Pulsar SQL suited for? I think it's for running a dashboard and for doing some operational looks, personally. I think that it gives you the ability to quickly look at an issue, quickly look and see what's happening right now. If you didn't know it, there's a REST API for Pulsar SQL. And with Pulsar SQL, you can actually call that REST API, get results back. And this is one of the things I really see fault with in the KSQL story, is that there isn't a programmatic interface to Pulsar SQL. So what you'd have to do is you would have to do whatever query that goes back into a Kafka topic that then we start consuming from. So I see that as there are certain things that are better or easier and more succinct to describe in Pulsar, in SQL. Those are things like group bys, distinct counts, order bys. I'd be looking at those sorts of things. Okay, Ankaras, docs seem to indicate that each consumer belonging to the same failover subscription on a partition topic would get different partitions assigned. Is that the understanding that it would seem to match with? Let's see, I'm trying to understand the question. Give me a second. Docs seem to indicate that each consumer belonging to the same failover subscription on a partition topic would. So with the failover subscription, you only get one consumer running. So in that sense, every partition would go to that single failover. So I'm not sure that sort of thing. There isn't a specific failover in Kafka. What you would do is you would have a single consumer, but use something like Kubernetes, for example, to monitor that consumer. And if that consumer went down, to spin it back up. Okay, Anonymous asks, if you have no Pulsar or Kafka and need something like this, would you go for Kafka or Pulsar? That's a good question. I actually help my clients do this. So kind of putting on my CTO hat, this is how I would evaluate the two. One is I would look at is there a killer feature in Pulsar that just makes it a no-brainer where we just have to go for it? For example, the whole MQ story, very strong on Pulsar and not as strong on Kafka. I would look at things like that. In terms of looking at what else is out there or making that decision, this is what I look at. I look at support in the open source community. I look at enterprise support. Are there companies actually offering support on this? So obviously with Pulsar, we have a few, and with Kafka, we have more. I'm not going to lie there. The other thing is on that community. Definitely the community for Kafka is bigger, but what I am seeing is a pretty significant uptick in the Pulsar community. So those are the ones, but I think the initial decision comes down to looking at what you have initially and then thinking about what the future looks like. For personally, I see the community for Pulsar getting bigger and bigger, especially now that we're getting some of these fundamentals behind us, some of these community behind us, and things like this. One thing I'd point out that I don't think is well known is I worked with one of the companies, one of the early companies, and I actually worked their booth in 2015. And in 2015, nobody knew what Kafka was. And we were at Strata. So Strata conference where you have some of the most technically adept people. Still, nobody knew. 2016, a little bit more. 2017, it became much more. So I guess the point there is in adoption and adoption cycles, there are going to be some very initial parts, but in general, I see that I think that the Pulsar community will grow, and I think the number of people using Pulsar is going to grow dramatically. Okay, Anonymous asks, what should you consider when migrating a production service from Kafka to Pulsar? I'm not sure if you mean operationally, developmentally, architecturally, probably all three. I would obviously start out by doing some initial QA. Maybe what we do is we start looking at how do we use that Kafka on that. Remember what Siji said yesterday, asterisk on Pulsar. Well, maybe what we could do is we could initially say, I'm actually not even going to rewrite anything. I'm just going to use whatever just going to change my backend to Pulsar. And that gives us a way to dip our toes in this, or maybe even just say, okay, from here on out, whatever we write new, and we'll start creating a rewrite schedule. We'll go back and rewrite things, but we could go through and start saying, not going to change anything. The other thing I would look at is architecturally, is there any differences? For example, if you're using heavy transactions, we don't have transactions in Pulsar yet. We may need to rethink that. I think that those are the initial forms that, these are the things I've helped my clients do. So you could think along those lines. So Anonymous asks, if I know Kafka, how long does it take to ramp up in Pulsar? The class itself, the class that I just taught is 2 days. So I would expect you within a team, if the team ran through that class and actually had a knowledgeable instructor to answer, here's what you do in Kafka, but I would say you could be writing some pretty good Pulsar code within 2 weeks, maybe 3 weeks. That also makes some assumptions about the team that you actually did understand Kafka to begin with. No offense, I see a common issue with self-taught people on Kafka is that they understand the Kafka API. Hey, I can read the Java docs. Do they understand how to use Kafka? And that's a very big difference. So if you really understand how to use Kafka, how to architect for it correctly, then I think you could have a pretty quick ramp up time of weeks. Next question from Anonymous is message ordering as strong as it is in Pulsar, as it is in Kafka? Yes. During the class, I actually go through that, but I would say there's the strong message ordering guarantee, just as strong. I would say that there's an even bigger thing, and that is, you know how, if you ever have a use case of round robin and ordering, you can't do that with Kafka. You basically have to say, it's in a partition, I just have to deal with that. As you saw with these Pulsar subscriptions here, we can do shared subscriptions and key shared. While these key shareds keep that order, while these round robin ones consuming on the same topic, same partition, same everything, gets them out of without an order with the round robin. So I think that's a strong thing where I did see some of those use cases in clients and teaching. Anonymous asks, when would you suggest Kafka over Pulsar? I think it's when Pulsar or your use case really aligns to something that Pulsar is a key value of Pulsar. One of those use cases that I said. I need strong replication. I need to do geo active replication, for example. If replication is really important and that you're dealing with that operationally, I would suggest you really look into how replication is done with Kafka. And I personally don't believe it's as strong. So I would look for those examples. Anonymous asks, a large downside I've heard about Pulsar is that it is newer, smaller community, and more complex. This makes it harder to jump in. What would you say to this? Not going to lie, it is a bit more complex. One thing I would say there, though, is that as you get into Kafka, as much as there's a particular company that just says it's easy, I disagree. I disagree that any distributed system is easy. And if you come in thinking that, you will fail. I've hit that too many times. So that said, as you get into the weeds, to the real nuts and bolts, to the difficulty of implementing things, and we're not just thinking, hey, this is an easy API, it becomes more complex. So yes, that two-tiered operation, the fact that there are different types of Pulsar subscriptions, I would say it's more complicated, but I would say that there's value to each one of those complications. I completely agree that the community is newer and smaller, definitely. But I do believe that that's going to grow. And I would say the last one from Abhishek, I've answered that, but look at those use cases that I call out.
Jesse, this was fantastic. Before we wrap here, people are probably going to say, what's the best way to get in touch with Jesse? How can we connect? What do you recommend? Is it Twitter, LinkedIn, your website?
Sure. Twitter, I'm at Jesse T. Anderson. LinkedIn, if you link with me on LinkedIn, just say that you came from here because I get a ton of spam. My website, jesse-anderson.com. You saw one minified URL that I put out there. And one last plug is that I'm about to publish my next book on management. How do we manage data teams? And that website is called datateams.io. And if you register there, you'll get notified once that book comes out.
So I will be registering for that because that sounds, I mean, that's fantastic. That's a much needed read. That's fantastic. Well, Jesse, since other folks can't clap for you, I just wanted to clap for you and say thank you so much. And folks, as mentioned before, this recording will be made available a little bit after the conference. So Jesse, thank you so much.
Thank you. Thank you, everyone.
Thank you.